Good morning all. Today we are going to see a topic measures of dispersion presented by Mrs.J.Pavithra, Assistant Professor, PG Department of Mathematics, Vellalar College for Women. First we are going to see about definition. Here the first point is measures of dispersions are descriptive statistics that describe how similar a set of scores are to each other. The more similar the scores are to each other, the lower the measure of dispersion will be. The less similar the scores are to each other, the higher the measure of dispersion will be. In general, the more spread out a distribution is, the larger the measure of dispersion will be. The next, which of the distributions of the scores has the larger dispersion? Here we are seeing the two bar diagrams. The upper distribution has more dispersion because the scores are more spread out, that is, they are less similar to each other. When we comparing these two diagrams, the first one, the scores are spread out scatteredly, and the second one is little bit low. So the dispersion of the highest score has the first bar diagram. There are three main measures of dispersion: the range, the semi-interquartile range, variance and standard deviation. The first one is range. The range is defined as the difference between the largest score in the set of data and the smallest score in the set of data, which means when we are giving the individual observation, we have to find out the largest value and we have to find out the smallest value, and we have to get the difference between these two values, that is our range. Here an example is given. What is the range of the following data? Here an individual observation is given. There are 10 digit numbers, and here the largest score is 9 and the smallest score is 1. So how do we find out the range? We have to find out the difference between the largest score and the smallest score. So the largest score is 9 and the smallest score is 1. When we are finding the difference, 9 minus 1, we are getting the range is 8. When to use the range? The range is used when you have ordinal data or you are presenting your results to people with little or no knowledge of statistics. The range is rarely used in scientific work as it is fairly insensitive. It depends on only two scores in the set of data, which means the largest value and the smallest value. When we are finding out the range, we need to give the importance to the largest value and the smallest value, and we will never have the sensitive about the remaining values. The next is semi-interquartile range. The semi-interquartile range, or SIR, is defined as the difference of the first and third quartiles divided by 2. The first quartile is the 25th percentile, the third quartile is the 75th percentile, and the formula for the semi-interquartile range is, that is, the first quartile and the third quartile is 75th percentile. So the formula is Q3 minus Q1 by 2. Q3 is nothing but third quartile and Q1 is nothing but first quartile, and divided by 2. This is the formula for semi-interquartile range. Here are few examples for semi-interquartile range. Here is an example. What is the semi-interquartile range for the data to the right? The data are given in the right side, which is in the tabular column format. Here the number is 2, 4, 6, 8, 10, 12, 20, 30 and 60. First we have to find out the 25% of the scores, that is below 5. So here we are finding out the value for 25th percentile, means we are getting the 5 is the first quartile. Next, 25% of the scores are above 25, that is 25 is the third quartile, which means the 75th percentile. So here we are finding out the 75th percentile, which is nearer by 20 to 30, which that can be seen in the right side. So the semi-interquartile range formula is third quartile minus first quartile divided by 2. So here we are finding out the third quartile value is 25 minus the first quartile value is, it is between the 4 and 6, which is a center value, which is 5. That is 25 minus 5 divided by 2, we are getting 10. So the semi-interquartile range for the given data is 10. When to use the semi-interquartile range? The semi-interquartile is often used with the skewed data as it is insensitive to the extreme scores. When we are having the extreme number of scores, we can opt the semi-interquartile range. Otherwise, we can just find out the mean value. The next type is variance. Variance is defined as the average of the square deviations. What does the variance formula mean? First, it says to subtract the mean from each of the scores. This difference is called a deviate or deviation score. The deviate tells us how far a given score is from the typical or average score. Thus, the deviate is a measure of dispersion for a given score. The next one is standard deviation. Standard deviation and variance is combined with a relationship, which is standard deviation is equal to square root of variance. If we need to find out the variance, that is nothing but your standard deviation square. Here there is a computational formula for the standard deviation and variance. When here first we are going to see the variance. When calculating variance, it is often easier to use a computational formula which is algebraically equivalent to the definitional formula, that is sigma squared is equal to summation x squared minus summation x by x the whole square divided by n, the whole thing divided by n, which is equal to, this can be written also as summation of x minus mu the whole square divided by n. This is the formula for calculating the variance. Next, sigma square is the population variance and x is a score, mu is the population mean and n is the number of scores. Computational formula example. If you are having an individual observation that is denoted as x in the first column, that is 9, 8, 6, 5, 8, 6. This is the given data and we need to find out x squared. The next column is x squared, that is we have to square the x value, that is 9 squared is 81, 8 squared is 61, 6 squared is 36, so on. Next column is we have to find out according to the formula, that is x minus mu. X is what is the given individual observation and mu is the given value, that is we have to find out the subtraction of the value, that is summation of first column we need to find out the summation x value, that is 42, and the summation of x squared is equal to 306 and x minus mu value is equal to summation value. If we are adding the value, we will get 0. The next column is we need to find out according to the formula x minus mu the whole square. So if you are squaring the third column, we will get the fourth column. So 4 1 1 4 1 1. If we are adding this, we will get 12. So we have to find out the variance, means we need the formula, that is we are having two formulas. One is summation x squared minus summation x by summation x the whole squared by n, the whole thing divided by n. Just substitute the value, summation x squared value is 306 and summation x the whole squared value is 42 squared divided by 6, the whole thing divided by 6. We are getting the answer is 2. And we are having one more formula, that is summation x minus mu the whole square divided by n, which is more easier than the previous one, that is 12 by 6, which is equal to, easily we are getting 2. Variance of a sample. Because the sample mean is not a perfect estimate of the population mean, the formula for the variance of a sample is slightly different from the formula of the variance of a population. That is s squared is equal to summation of x minus x bar the whole square divided by n minus 1. Here we know s squared is a sample variance and x is a score, x bar is a sample mean and n is the number of scores. Measure of skew. Skew is a measure of symmetry in the distribution of scores. Here we can see the three normal distribution curves. The first curve is a positive skew, the next one is a normal skew and the last one is a negative skew. I'll explain this in a detailed manner. If s cube is less than 0, then the distribution has a negative skew. If s cube is greater than 0, then the distribution has a positive skew, and if s cube is equal to 0, then the distribution is the symmetrical. The more different s cube is from 0, the greater the skew in the distribution. Here we can see the vertices, which is leptokurtic, mesokurtic and platykurtic. If s cube is greater than 4, it is leptokurtic. Mesokurtic means is s4 is equal to 3 and platykurtis is s4 is less than 3. Leptokurtic means which is a greater than 3 value, mesokurtic is equal to 3 and platykurtis is less than 3. Kurtis measures whether the scores are spread out more or less than what would be is in a normal Gaussian distribution. Kurtosis, the definition for mesokurtic, leptokurtic and platykurtic is given detailed manner, and the measure of kurtosis formula is given by S4, which is equal to the formula S squared, S cube and S4. What are all the name of this can be given collectively? The variance S squared, the skew S cube and the kurtosis S4 describe the shape of the distribution. Thank you.